Okay, so students are going to start partial quotient division. This is basically the bridge between the work that they do that's super, super basic in third grade, things like 24 divided by 6, where they actually draw 6 circles and then put them, put things in groups like this, to what they need to eventually do in 4th grade, which is something like this. And in 4th grade, they use the partial quotient method, where they take and they start to subtract amounts that maybe they have in their head. Like, I know 240 divided by 6 is 40. Yeah, sorry, that should say 12. So they're doing work like this to kind of get the right answer. Let me do that again. Right? This is the work that we want them to do when they get into 4th grade. But you could see how, like, if kids are just drawing things into groups and they don't have any kind of like bridge between this and this, then they're really, really, really going to struggle. And so we're going to work on them solving problems, some basic problems like this, some problems like where they can really just use place value and they're going to get a nice even number, to problems more like this, right, which are going to be more here, where we're going to think of it as like 72 divided by 6 and then maybe 6 divided by 6. So we're going to get into partial products without getting into like really, really, really big numbers. And so that's the plan, starting with dividing powers of 10 and doing this kind of stuff, and then by the end of the week getting more into this and using an area model to reinforce it. Because frankly, this is new territory for us. I've never done it. We're going to kind of have to grapple through, and I don't know if the order is exactly right, and we're going to have to do a few different things, but I think it's going to be good. Ooh, it got all kinds of noise. Excuse me. All right, here we go. So let's model all 3 of these division problems, and you're going to use actual place value blocks and lay them out. There's 8, right? And we're going to put them into 2 groups. So let's do it. 1, 2, 3, 4, 5, 6, 7, 8. And I want you to have like plates and place value blocks, and you lay it out. And they say, okay, now we're going to do 80. Here's how I make 80. And 2 groups. 1, 2, 3, 4, 5, 6, 7, 8. So we get 8 divided by 2. There's 4 in each group. 80 divided by 2, there's 4 in each group, but it's 4 tens, so it's 40. And then 800 divided by 2. And you're going to do that same exact thing, and you're going to get 4 in each group, but it's going to be 4 hundreds. And so you're going to do this work, and you're going to be like, notice that really, when I did it, it was still 8 divided by 2. Right? It's just here, it was 8 ones divided by 2, made 4 ones. 8 tens divided by 2 was 4, and they were still tens. 8 hundreds divided by 2, there's still 4 in each group, but it was 4 hundreds. So what that means is when we divide a number in a larger place, it is just like single digit division. In other words, it's just like this, except we need to keep that same place value. In other words, if we're dividing tens, my answer is still tens. If we're dividing hundreds, my answer is still hundreds. And we saw that, right? By the way, we do this by keeping the same number of zeros, because that 0 tells me that it's tens. 1 0 here means I'm going to need 1 0 here. 2 zeros is what gets me to that hundreds place, so if I have 2 zeros here, I'm going to need 2 zeros here. Notice, teachers, how I'm going back and forth between those 2 slides. So now we just keep dividing, and we're going to think about why this makes sense using a place value explanation. So you let kids kind of work, you let kids, whether they draw a picture or they know the fact in their mind, and both of those explanations should be good. Whether they're like, well, I had to do 1, 2, 3, 4, 5, 6, and I got 3, and then I put on zeros. Or whether they said, I did 6 divided by 2 was 3, but then I needed to think in my head 300, put on the 2 zeros. That's great. And why does this make sense? Well, hundreds are going to stay hundreds. Keep going. Keep doing both of those explanations side by side, calling on different students. Keep talking the place value explanation, right? The final thing is this also makes sense, and then we're going to approach it kind of from a different angle. right? Because this is fairly rote, and I think we need to get our thinking cap on a little better. I will say these present a challenge because here it's 12. It's not 12 thousands though. It's 1,000. If we're talking about the 12, it's 1,200. So my answer is 1,200. So flag that for you. Honestly, pretty rote, except for that kind of thing that can be hard if we don't have really strong place value sense. But now let's think about it going backwards, right? This also makes sense because when we learned, because we learned that when we multiply by bigger places, we keep the number of zeros, right? We learned 4 times 20 is 80. We learned 3 times 300 is 900, right? Let them give you these answers really quickly. Great. And so let's think of this as a division problem, right? It would be 80 divided by 4. 8 divided by 4 is 2. Do you see how we get that same thing? Right? Or 900 divided by 3. 9 divided by 3 is 3. Keep the hundreds. Look, we get what we got when we were multiplying, right? Finish this up. And so we can rewrite 80 divided by 4 as a missing factor problem. We can think of it as 4 times what makes 80. We know 4 times 2 makes 8, but it's going to be 4 times 2 tens. And let's show what this looks like with a place value drawing. And so you're having the kids say, I'm going to do 2, 2, 2, 2, right? There's 80 split into groups of 2. Or groups of 20, my bad. And so then they keep working. So they're kind of approaching this in two directions to really solidify that relationship between multiplication, but now with place value.